welcome to my channel. Today we'll be studying on multiplexers and we would learn what it does, examples of it, but then of course first of all we would want it's a presentation on multiplexers. We will be talking mainly about the 4 to 1 multiplexer, but I won't talk much about the 2 to 1 multiplexer and the 8 to 1 multiplexer. A multiplexer can also be called a max. Here in this diagram we have 3 max, which is a 2 to 1, a 4 to 1, and an 8 to 1 respectively. A 2 to 1 max has 2 inputs and then 1 output and has 1 selection line. So as a 4 to 1 max has 4 inputs, 2 selection lines, and still 1 output. Whereas an 8 to 1 multiplexer has 8 inputs, 3 selection lines, and 1 output. On the 4 to 1 multiplexer, the image here represents a logical circuit diagram of a 4 to 1 max. The image in the diagram of a logical circuit, the diagram consists of lines of various logic gates, which will be explained down the line. At the top left are 2 gates labeled S0 and S1, and then these gates are put NOT gates. They are, which is down the selection line. The selection line here are always NOT gates, and these 4 input lines are mostly AND gates, and then for the output most of the times is the OR gates that is represented, or which represents the output. So to explain further on what we are talking about, we say these 2, X0 and X1, are both NOT gates, and then they are connected to be selection lines to the multiplexers. We have 4 AND gates, which is I0, I1, I2, and I3, and we have an OR gate which receives all inputs and then gives it out in 1 output. So in a multiplexer can be expressed as a lot, but here we are focusing mainly on implementing Boolean functions of a 4 to 1 multiplexer. And we know that in a multiplexer, or in a Boolean function, whenever there is a 0, this is said to be a true expression or a false. When there is a 0, we know that it is a false expression. Excuse my writing. We know that whenever it's a 0, it's a false, and whenever it's a 1, we know that then that means the expression is true. Okay, so here we have a 0 and a 0, that is whenever the two multiplexers whenever the two NOT gates both give us a 0 and here also gives us a 0, we find out that here gives us an output whilst all these sides are left out alone. All these lines are not being served when there is no power coming from our selection lines, our two selection lines, which are both NOT gates. So we find out that when they are both zeros, he is the only one working, and then he gives an output based on only his, and the others are cut short. Whereas if this side is a 0 and here is a 1, we get to see that this side is also cancelled. Yes, it is cancelled, and only this side works. Only I1 works. Only I1 has an output, whereas it will move on and then give an output to the OR, producing it also based on just its signal, and then the rest are cut off. That is what happens when this is also 1 and it's a 0. He is the only one that has an output, and then when they are both 1 1, we know that I3 gives us an output. So that is what the representation on the table is telling us, that if it's a false, or if there is no power, that is 0, then we will have I0 giving us an output, and then the rest off accordingly as it is here. Want to know where multiplexers are mostly used, and then we find out that in a computer memory, most multiplexers are used in a computer memory, especially the 4-to-1 multiplexer, so as a full adder, a Boolean function implementation, that's what we just checked out, and then it is also used in control circuits, audio and video source selection. Now let's see input selection lines formula. The formulas in finding number of input lines, numbers of input lines. Number of input lines is equal to n, number of selection lines is equal to m. So to know the number of input lines, we say the formula here is 2 raised to the power m. So if we want to know for 1, say 2 raised to the power 1 selection line, and then our answer given is will be 2. Whereas when we put 2 in place of m, we have 2 raised to the power 2, where our answer will be 4 input lines. When we have 2 raised to the power 3, we get our answer to be 8, and then so on and then so forth. So based on your selection lines, you can find your input lines, as well as the other way around. Sometimes you might have the input lines and then you want to find the selection lines. You can also send them, as in if I have 4 input lines giving me 2 raised to the power question mark on the selection lines, I would then break this down into the same base. So 2 raised to the power 2 is equal to 2 raised to the power, let's say L. Then here two indices, we know this will be left out, giving us 2 is equal to L. Then now we know that there are 2 selection lines. Thank you very much. I hope you had what you needed. See you next time on my channel. Bye bye.